This lesson is titled Solving Equations. It's going to be just a general guideline for solving any basic linear equation. And when we say a linear equation is one which has only one variable, meaning just an x, just a y. We're not looking at equations with multiple variables. Give me a second to write that out. Okay, so again, a linear equation is an equation that has only one variable. The way we like to think about equations is like a scale. We always want equations to be balanced. So for this scale, the left side equals the right side. Whatever you do to one side of an equation, you have to do to the other side of an equation. So for example, if I were to add on one more block onto the left side of the equation and I didn't add it to the right side of the equation, then it would bring the left side of the block down. And we don't want that. So if I add one block to the left, I have to add one block to the right to keep the equation balanced. And that general principle is what allows us to solve equations. So keep that in mind and just remember, what you do to one side, you have to do to the other. These steps are some guidelines for solving all types of equations. So step 1, it says, if necessary, expand any brackets and collect like terms. Step 2, if necessary, remove the unknown from one side of the equation. Aim to do so the unknown is left with a positive coefficient. Okay, well, we'll see some examples that describe that. Then you use inverse operations to isolate the unknown and maintain balance. So when we say inverse operations, that means if we're adding, then we're going to subtract. If we multiply, then we'll divide. It's always the opposite. And the way I think about it is inverse operations are performed in reverse order. So you start with addition and subtraction, then multiply, divide, then worry about exponents, and then parentheses. And then the fourth step, which is the most important, is to check your solution. Make sure that the left-hand side equals the right-hand side. The examples I'm going to work through, I'll leave the steps up so you can press pause and you can have those steps with you. It's a good idea to try and commit these to memory so you don't have to rely on them too much, but the more you practice it, the less you'll feel like you have to memorize it. It'll just become second nature. Okay, so here's our first equation. X plus 7 equals 4. So step 1, if necessary, expand any brackets and collect like terms. Okay, well, that's not necessary, so step 1 is done. Step 2, if necessary, remove the unknown from one side of the equation. Well, we only have it on one, so step 2 is done. Step 3, use inverse operations to isolate the unknown and maintain balance. Okay, so remember, we're going to do order of operations in reverse order. So you ask yourself, is there anything that I can add or subtract away from x? Well, in this case, we can subtract a 7 away. So to keep balance, we subtract 7 from both the left-hand side and the right-hand side. So positive 7 minus 7 cancels. And our answer that we're finding is that x equals negative 3. This is called isolating the variable. We want the variable to be all alone on one side of the equation. All right, now the most important part is you want to check your equation to make sure that it satisfies the equation. So to check, plug in your answer and try and evaluate it. So negative 3 plus 7 is in fact positive 4. We have a balanced equation, So here we go. Everything's great. Our answer is x equals -3. All right, let's try this one. 5 times y equals 45. So step 1, we don't need to do anything. Don't have to do anything in step 2. Inverse operations, 5 times y. So we want to do the opposite of multiplication. So in this case, that would be division. 5 divided by 5 cancels out. That's 1. So we'll have y equals 9. And then step 4, check your solution. So that would be 5 times 9 equals 45. Well, 5 times 9 does equal 45. So that checks, and our answer is in fact y equals 9. Okay, try this one on your own. See how you do. Press pause, and when you're ready to check your answer, press play, and hopefully we'll get the same answer. So the answer is m equals 14. If you got that answer, great, congratulations. Go ahead and move on to the next page. If not, let's take a look and see if you can pinpoint your mistake. Well, we have m divided by 7. There's nothing to expand, no variables to collect. All we have to do is deal with this over 7 part. Well, m over 7, that's the same thing as divided by 7. So we're going to multiply both sides by 7. So 7 over 7 will cancel, and m equals 14. Now to check yourself, we would say 14 over 7 equals 2. Well, in fact, 14 over 7 is 2, so it checks. Okay, let's try this next one. We call this one a two-step equation because we would have to use 2 steps to find out what x is. Now, if you remember to do inverse operations, start with addition and subtraction, and then work your way backwards. So instead of trying to divide by 5, I want to subtract 9 first. So positive 9 minus 9 cancels, and we will get that 5x equals 15. Divide by 5 now, and you'll have that x equals 3. Now let's check. 5 times 3 plus 9. Does that equal 24? Well, 5 times 3 is 15. 15 plus 9 is 24, so it checks. Our answer is x equals 3. Okay, so try this one. Press pause, and let's see how you do. The answer is n equals 18. If you need to see the work, keep watching the video. If not, feel free to fast forward to the next example. All right, so we are going to do opposite operations. We're going to start by adding 7 to both sides. So positive 7 minus 7, those cancel. And then negative 1 plus 7 is 6. N over 3 equals 6. So this is dividing by 3. We'll multiply both sides by 3. 3 over 3 will cancel. 18 equals n. And just for time's sake, I'm going to not show you the steps for checking, but to check, you would plug it into the equation. All right, this one is one where step 1 is going to apply because we have 7x minus. It's actually easier if we collect these two like terms. 7x minus 4x combines to be 3x. Now try and use inverse operations. 3 times x. So we'll divide both sides by 3. 3 over 3 will cancel, and x will equal 7. So let's try checking that answer. 7 times 7 minus 4 times 7. Does that equal 21? Well, that would be 49 minus 28. 49 minus 28 is, in fact, 21. Okay, moving on. Why don't you try this one on your own? Press pause and see how you do. If you followed all of the steps correctly, you should have gotten that A equals 6. Well, let's see. Opposite operations, we want to subtract 4 from both sides first. So positive 4 minus 4 will cancel, and A over 3 will equal 2. And then A divided by 3, so to cancel out the dividing by 3, we'll multiply by 3, and A will equal 6. Here's an equation where step 2 is going to apply. Do you notice how we have a variable on both the left side and the right-hand side of the equation? We want to move that variable to one side. The guidelines from our book say that we want to have a positive coefficient for our variable. That's just a recommendation. Sometimes dividing by negatives can complicate things. So if I move the 6t over to the left-hand side, that would give me a positive 2t, versus if I moved the 8t over to the right-hand side, that would give me a negative 2t. So it might be a good strategy to move the 6t over. That way you're left with a positive coefficient, positive 2 times t. If you move the 8t over and you get a negative 2t, you'll get the same answer. So just a suggestion, not a rule. Okay, now we can start isolating the variable. So we'll subtract 5 from both sides. 2t equals negative 4. Then we're going to divide both sides by 2. And so t equals negative 2. Okay, try the next one on your own. Press pause, and when you're ready to check your answer, press play. The answer is b equals negative 7. So when I worked this, I decided to move the 8b over to the left-hand side, and that gives me positive 2b. Then I'm going to subtract 18 from both sides. So 2b equals negative 14. Then we're going to divide both sides by 2, and you'll get that b equals negative 7. Again, you want to check your answer, but just for time's sake, I'm going to move on. All right, this is our last example. We need to use step 1 again. It says, if necessary, expand any brackets and collect like terms. Remember, brackets. So I'm going to distribute the 5 to both n and 2, and I'm going to distribute 3/5 to 5 and 10n. So this is going to be 5n plus 10 equals, well, 3/5 of 5 is 3, and 3/5 of 10 is 6. Now that we've expanded the parentheses, we need to move on to step 2. If I move 6n over to the left side, that would give me a negative n. That's fine, I can do that. If I move 5n over to the right, I'll get a positive n. So I'm going to move it over to the right. I'm going to subtract 5n from both sides, and that'll make it 10 equals 3 plus n. And then when I subtract 3 minus 3 will cancel. 10 minus 3 is 7. So I have 7 equals n. So my solution is n equals 7. All right, so that's a very basic overview of the steps to solving equations. Be sure to always check your answers. I know I didn't check all of them in this video, but make sure you're checking your work and make sure you're very careful with all of your arithmetic. But if you keep practicing and you always follow these 4 simple steps, you should be able to solve any and every equation.